This video is on solving literal equations for a variable. So in these examples, we're going to solve each formula for the given variable. Something to point out that I didn't write in the directions here, but make sure you see it. We're going to assume all variables are positive real numbers. If not, it can lead to some errors that we might get, and we'll talk about it as we go along the way. So we're going to assume all variables are positive real numbers when we do this. So we've done this before in previous sections, so you might have seen the videos that we've done previously. We just didn't have exponents in them is really the difference. So here we got, v is equal to 1/3 pi r squared h. And we're trying to solve this for r. What that really means is I want to get r by itself on one side of the problem. Now, don't let there being extra variables throw you off. You still do what you normally would do. If I see an equation with fractions, the first thing I want to do is multiply, every term by the LCD. And in this case, the LCD, since there's only one fraction, right, the 1/3, the LCD here is 3. So I'm going to multiply 3 to each term. In this case, v is its own term. This whole side is one term, right? Terms are separated by addition or subtraction symbols. So it's really 3 times the v and 3 times this side here. So I have 3v is equal to, here the 3's are going to cancel. That's why we did this. Right, these 3's cancel, and with 1 pi r squared h would just be pi r squared h. Now remember the goal, solve for r, get r by itself on one side. Well, what's the operation going on here between pi r squared and h? Well, these are being multiplied. So how do I get rid of the pi and the h to get it away from there, to isolate the r, or the r squared in this case? You want to divide both sides by pi h, because these are being multiplied, so to get them over to the other side, you divide. So we end up with 3v over pi h is equal to r squared, because the pi's and the h's cancel. And then how do I solve this for r? Well, to solve this for r, you have r squared, you want to take the square root of each side. Now typically when you take the square root, we're going to write plus or minus in front of this. But because I'm assuming all variables are positive real numbers, I know this has to be positive because r is going to be positive. So I don't have to worry about putting the plus or minus here. So I end up with r is equal to, now we get the square root of 3v over pi h. Remember, that's the same as the square root of 3v over the square root of pi h. And, we want to simplify this completely. I mean, we want to rationalize this. You can't have radicals in the denominator. So I'm going to multiply by what? Well, to rationalize, you multiply for a square root by itself. Square root of pi h times the square root of pi h. So this gives us, I'll say r equals, so this is that side, r equals, now square root of 3v times the square root of pi h is the square root of 3v pi h, over in the denominator, square root of pi h times square root of pi h. Remember, the square root of something times itself just gives you the inside, right? Just gives you pi h, and the radical's gone. Because really what you're doing is you're taking the square root of pi squared h squared, and the square root of each of those just be pi h. So the square root of something times itself just gives you whatever is on the inside. And then that would be the answer. Remembering that the denominator is not under the square root anymore. So we rationalize this. The other thing to point out, since we assumed all variables are positive real numbers, you didn't need to put a plus or minus in front of this. Let's take a look at the next one. We got a squared plus b squared equals c squared, and we're trying to solve this for b. So first thing you want to do is isolate the b squared term, isolate the term that has b in it. So to do that, we have to move the a squared to the other side. Well, how do we do it? Well, if it's being added here, we subtract a squared. Subtract a squared. So I end up with b squared equals c squared minus a squared. Now remember the goal, solve for b. So I get b by itself. To get b by itself, well, if it's squared, I want to take the square root. If I take the square root of one side, I take the square root of the other side. Now remember, you're taking the square root of each side when you do this, not the square root of each term. You can't do that. That's not equivalent. So I'm taking the square root of this whole thing. You can't take the square root of the c and the a individually. So square root of b squared is just b. It's equal to, now normally I'd put plus or minus here, but remember, since all variables are assumed positive, I know I'm going to take the positive. It's equal to the square root of c squared minus a squared. Then you have to ask yourself, can I simplify any further? Well, c squared minus a squared, you can't take the square root of individual terms, right? So inside of a radical, you can only take the square root of each piece if it's multiplication or division, not if it's addition or subtraction. So I can't just say this is c minus a now, because that'd be incorrect. You could factor the c squared minus a squared. It's the difference of perfect squares. You'd have c plus a times c minus a, but that doesn't help you take the square root. So really, that's it. It's a pretty quick problem. You just have to understand when you're done. So b is equal to the square root of c squared minus a squared. Let's take a look at C and D. You might want to pause the video and try these two on your own. They're kind of similar to the previous ones, but a little different. So we got D equals the square root of L squared plus W squared plus H squared. And we're trying to solve this for W. So first thing is I have to get inside of this square root to get to the W, to try to solve for W, try to get W by itself on one side. So how do I remove the square root from each side? Well, to remove the square root, I would have to raise to the second power, right? You remember it's raised to the index of the root. So I'm going to square this side. I'm also going to square this side. So I end up with D squared is equal to, on the right side, I have L squared plus W squared plus H squared. Now remember the goal is solve for W, so I want to get the W term alone. Well, how do I do that? Well, I got to move the L squared. So I subtract L squared from each side. And I also have to move the H squared over, and since it's being added, I'll subtract H squared from each side. So on this left side, I'll write it out as D squared minus L squared minus H squared. The order of these doesn't matter, but the sign on the term does. The D squared was positive, the L squared was negative, the H squared was negative. And it's equal to, on this side, we isolated the W squared, so it's equal to W squared. Well, how do I get W alone? Well, if this is W squared, and I got to get rid of the squared on it, what do? Well, I take the square root. Remember, when you take the square root of one side, you take the square root of the entire other side. You can't do it term by term, right? Just like we talked about up here in this previous example. So now you have the square root of W squared here on the right is just W. Remember, I don't put plus or minus here because I know that we're assuming the variables are positive, so I know I'm assuming positive. So I have the square root of D squared minus L squared minus H squared. And from there, can I simplify this any further? Remember, the answer is no. You can't take the square root of individual terms, right? You only take the square root of the entire expression. So that's it. That's what W is equal to. But you should show the work to get here and have an understanding of why we did what we did. For the last one here, we got A equals P times 1 plus R squared. We're trying to solve this for R. So to solve for R, I have to get into these parentheses. And to do that, I have to get rid of this squared. Before I do that, I have to get rid of the coefficient. All right, so I got to move this P first. You can't, sometimes what people do is they try to take the square root of each side right away, but then you have this radical P that's in there that you might miss. So first you have to isolate the part that's being raised to the power. Then you can take the root of it. So this is P times 1 plus R squared. So to move it to the other side, I'm going to divide by P and divide by P. So I have A over P equals, this is 1 plus R, the quantity squared. Now remember, the goal is to solve for R. Well, how do I get into here to solve for R? I have to get rid of that squared. To get rid of something squared, you take the square root. Take the square root of one side, you take the square root of the other side. Now remember, I'm not writing plus or minus because I'm assuming the variables are positive. So on this right side, it's just 1 plus R now, because the square root of something squared is just the inside. The square root of A over P is really the square root of A over the square root of P. Remember, if you have division or multiplication inside of the square root, you can take the root of each piece individually. Now the reason I'm doing this is that, I want to simplify this radical first. So before I solve for R, let me simplify this here. I have to rationalize it. If I have the square root of P down here, how do I get rid of the radical in the denominator? Well, you multiply by the square root of P. Whatever you do in the denominator, you got to do the numerator. So I multiply by the square root of P. So the numerator becomes the square root of A times the square root of P, which is the square root of AP, all right, over square root of P times square root of P is just going to be P. And now what do we do? Well, this is equal to 1 plus R. To solve this for R, I'm going to subtract 1 from each side. So I end up with negative 1 plus the square root of AP over P. Make sure that only the square root of AP is over P is equal to R. And then that's your answer. You've isolated R. It's important that you know how to rationalize and that you do rationalize, or otherwise you will get the answers incorrect. But this is something we've done in the past. The only difference between this now and what we've done in the past is that we're dealing with the roots and the radicals here. Hopefully this video helped review solving for literal equations. Remember that all of the variables being assumed positive are what's allowing us not to write plus or minus on these radicals as we do it. Otherwise you should be writing plus or minus as you go through the problems.